Hello everyone, we will continue on the same example to draw the block diagram, and these are mathematical equations in state space representation, and in the last video we discussed the matrix form. Now for the block diagram we will make a connection between the input and output using these equations. So we will convert these equations into block diagram representation format. So before that, we should decide which is our smallest parameter. What we said during the decision of the state variables are the smallest set of the variables. But in some cases, for example, in our example, we have dependent parameters. So because of this, we wrote the first differential equation. So from here, we can say x and y are dependent to each other, and x is the smallest parameter. We can obtain x from y. So because of this, we can say our last parameter, the final parameter on the block diagram will be x, and the system will start to operation with the inputs, which is f. We don't have any extra input for this case, and now we will try to make a connection between fa and x to write the equations in block diagram form. Okay, so for x, what we need to obtain two parameters inside the block diagram, x dot and y dot. So to clarify the block diagram drawing, let's start from the final part. X can be obtained from the x dot. So if we take an integral of x dot, we can obtain the x. So we need an integrator block from x dot to x. And x dot, which is also equal to v. So that part is, this explains the first equation of the example. For the second equation, we need another parameter, which is v dot, because after we add some parameters, finally we will obtain the v dot in the second expression. So because of this, we need to use one more integrator block, which input is v dot, and after the integrator we can obtain x dot or v. Okay, so for the second expression, what we need to obtain these parameters. There are different ways, but simply let's try to obtain the parameters inside the parentheses. For example, what we have k times x. So we need a gain block with the coefficient of k, and the input of this block must be x. And after this representation, the output of this block will be k times x. And we can obtain the first part of the parenthesis. Then for the second part, what we need? B times v. B will be multiplied by its input of v. Then we have b times v. And also we have fa here, which is used inside the parenthesis of v dot equation. So let's use a summing junction and let's obtain the parenthesis of v dot. What we have, first of all, let's say we have fa, and the signs are important. The sign of the fa is positive. Then bv will come with the negative sign. And finally, for the summing junction, we have k times x, again with the negative sign. Okay, we obtain this parenthesis. Then what will happen? Then we need one more gain to multiply this parenthesis with 1 over m. So we have a gain block which includes 1 over m. Then the output is equal to v dot. So that means you can connect directly to here. Okay, so this is the first way. Also, you can connect the blocks as k over m, b over m, and fa over m can be written before the summing junction. The order of the blocks doesn't matter. The aim after the block diagram drawing to obtain the equations exactly. So if we can obtain the same equations, the place of the blocks, the order of the blocks doesn't matter. Thank you for watching.